In this exercise, we'll create a T-data or time-based model constrained by a water level surface at the top and a bedrock surface at the bottom. First, we'll need to create the water level grid model. We will be creating models for the date of February 14th, 2017. In the main Borehole Manager window, click on DH01, then click on the Water Levels tab. Note that there are two aquifers and water level depths from several different dates. Choose Aquifers Plan Map from the main menu. Enable the time filter at the top of the menu. Select the exact option. Specify the date as 2/14/2017. Click on the Main Options tab. Click on the Grid Model tab. Click on the down arrow icon within the Aquifer selection prompt. Select Aquifer 1. Set the grid type to superface or top elevations. Click on the Modeling Options tab and set the algorithm to Trend Polynomial Second Order. Click on the Options tab and enable the High Fidelity option. Enable the 2D Grid Map option. Enable the Colored Intervals sub-option. Select the Min to Max color scheme. Click on the pull-down arrow and select the Cold to Hot Light option. Turn on the Contour Lines option. Enable the Map Overlays option. Turn on the borehole locations. Enable the Symbols and Aquifer Data labeling. Set the aquifer labeling to Aquifer 1 and annotate the surface depth. Click the Continue button. The program will interpolate a grid model for the groundwater elevations for the specified date. This grid is displayed as a color-contoured map within the new Untitled tab at the top of the Aquifer Data to Plan Map menu. Close this program by clicking on the X in the upper right corner of the menu. Click on the Project Manager tab within the main RockWorks menu. Expand the Grid Models group. Notice that in the process of interpolating the aquifer top, the program also created grids representing the aquifer base and the aquifer thickness as of February 14th, 2017.
T-data, meaning time-based data, is just like I-data or interval-based data, except that each sampled interval has a date. This is how we accommodate data such as groundwater contamination that may change over time. In this exercise, we'll create a T-data solid model that will be constrained above by the aquifer grid that we just created and below by the basement top grid that we created in a previous exercise. Start by launching the T-data solid program. Make sure that the time filter is activated and set for an exact date of 2/14/2017. Click on the Main Options tab, activate the Create New Model option, and set the name of the solid to be created to arsenic_2_14_17.rw_mod. Set the T-data track to arsenic. Set the modeling algorithm to Inverse Distance Weighting or IDW Advanced. Set the horizontal weighting exponent to 2.0 and the vertical weighting exponent to 5.0. This will create a model that is horizontally biased, meaning that the interpolation will give preference to coplanar points when interpolating the voxel node values. Set the search method to all points. Click on the Special Options tab and enable the Superface filter. Select the Manual option and select the aquifer that we previously created as the upper filter. This will prevent the program from interpolating any voxels above the February 14th, 2017 potentiometric surface. Enable the subface filter. Based on the assumption that the basement rock is impermeable, We'll set the filter type to manual and use the basement top.rwgrd surface as a lower constraining filter. This will prevent the program from interpolating any voxels below the basement surface. Enable the Create 3D Diagram option. Set the block diagram type to full voxels. Set the color scheme back to min to max. Enable the legend option. Then enable the color option and change the color legend title to arsenic. Click the Continue button to proceed. We'll now use this diagram depicting the arsenic contamination model to introduce the 3D cutaway view capability within RockPlot 3D. Right-click on the T-Data solid item within the data tree. Click on the Add Cutout option within the pop-up menu. The solid model cutout dialog will now appear. Select the southeast corner for the cutout. You can adjust the cutout dimensions by dragging the circular icons, or you can change the coordinates manually. These integer coordinates represent the voxel count relative to the lower southwest corner, or 0, 0, 0. When you are finished, click the Apply button. The model will be redrawn with the cutout applied. The cutout can be turned off by unchecking the New Cutout sub-option within the data tree. Note that you are not limited to a single cutout. You do not need to save this diagram, so go ahead and close the borehole T-Data to Solid program by clicking the X within the upper right corner of the menu.
In this exercise, we'll create a 2D contour map of T-data for a specific parameter and date. We'll also experiment with the effects of logarithmic interpolation. First, we'll create a histogram showing the measured values for arsenic on February 14th of 2017. Launch the T-Data histogram program. Make sure that the T-Data track is set to arsenic. The time filter at the top of the window should still be enabled. Click the Continue button. Note that the majority of the T-data measurements fall below a value of 100 or so, with only a few measurements above 100. For data sets such as this that range over multiple orders of magnitude, the logarithmic interpolation method may come in handy. To demonstrate how, let's create some 2D contour maps of arsenic for this date. You do not need to save this diagram, so close the T-Data histogram program. Run the Statistics Map program that is located within the T-Data pull-down menu. Based on the last few steps, the T-Data track should be set to arsenic, and the time filter should be set to exact and 2/14/2017. Set the map type to Z equals highest value. If there is more than one measurement for a well, for example, if you have more than one screened interval, the program will use the highest value when interpolating the 2D grid file. Click on the Output tab and set the name for the file to arsenic 2/14/17. Click on the Gridding Method tab and set the algorithm to inverse distance. Turn off all the gridding options except for the declustering. Turn on the 2D grid map. Enable the colored intervals, contour lines, labeled axes, map overlays, and peripherals. Configure the borehole labels to show the T-data values. Set the label font size to 1. Click on the Continue button. The final map shows a single large anomaly centered on the point with an arsenic value of 400. Click on the Main Options tab. Select the Gridding Method tab, then the Options tab. Check the logarithmic option and click on the Continue button to regenerate the map. The influence of the 400 ppb point is less pronounced within this new map, thereby allowing us to see other possible point sources for the contaminant. When the logarithmic option is enabled, the program will temporarily convert all of the control points to their log base 10 equivalents. It will then perform the grid interpolation and convert the grid node values to their antilogs, thereby diminishing the overall influence of outlier values.